We continue the session number 9 with the question number 10. Question number 10, we have this equation, and they ask what is the largest possible value of S. We know that the absolute value of A equal to B if and only if A equal to B or A equal to minus B. Applying this, we can write the absolute value of T at S, subtract number 3 equal to number 5. The absolute value of T plus S, subtract number 3 equal to minus 5. Hence, we have the absolute value of T equal to 8, subtract S, the absolute value of T equal to minus 2, subtract S. Because of the absolute value of T is greater than or equal to 0, we can see that 8 subtract S is greater than or equal to 0, and minus 2 subtract S is greater than or equal to 0. And finally, we have S is less than or equal to number 8, and S is less than or equal to minus 2. So the largest possible value of S is number 8, option D. Question number 11. A company produces a total of T clocks each year at several different plants. Here, the total production is 3 times the amount produced in plant A. That means T equal to 3 times A, or we can write A equal to T over 3. Plant B produces half the amount plant A produces. That means B equal to A over 2. A over 2 equal to T over 6. That is a 1/6 T, option E. Here they asked about the proportion of the total production produced in plant B. Question number 12. In the figure below, BC is parallel to DE, and point B is at the midpoint of AD. The midpoint. Hence, we can say that C, the point C is also a midpoint of segment AE. And we have BC, the measure of the segment BC equal to 1 second. The measure of the segment D. If the area of triangle ABC is 12, to calculate the area of the triangle, we need to draw the height of that triangle. For example, we draw from the point A. We draw a line which is perpendicular to BC. Here, AH is the height of the triangle ABC. And from the information in the question, we have the area of triangle ABC equal to 1 second AH times BC equal to 12. They ask about the area of a triangle IDE. We do the same. We draw the height of the triangle of the height of the triangle IDE from the point A. We also draw a line which is perpendicular to the segment DE here at the point K. AK is the height of triangle IDE. Using Taylor's theorem. We easily see that AK is twice of AH. With the same ratio, if we take AB over AD, and now we can calculate the area of a triangle IDE. The area of triangle IDE equal to 1 second. AK is the height times the base DE. We use this BC is 1 second of DE, or DE is twice of BC, and AK is twice of AH. And so we have here 1 second times 2 times AH, 2 times BC. We can easily see that the area of a triangle IED is 4 times of the area of triangle ABC, and the final result is 4 times 12. It is 48. Option D. Question number 13. First, we need to calculate the value of function fs when x equal to number 2. Look at the graph. We can easily see that there is at this point is 2, and the value of function fx at number 2. Hence, we have the value of f at s equal to minus 2. And we look at the graph of the function gs. We have the value of function g when s equal to minus 2. And this point is the number 4. This point is minus 2, and the value of the function gs when x equal to minus 2. There is a number 4. Number 4, that is option E. Question number 14. The graph of a function h of x is shown below. Which of the following is the graph of this function? To be easy to follow, we call this graph here the graph C, and the graph of this function is the graph h. To get the graph h, we need to do 2 actions. two actions to be done. First, we need to shift the graph C left 2 units, become the graph C1, for example, and then we continue to shift the graph C1 up 4 units. And now we look at the graph C. We take this point. Maybe you ask me why do I choose this point? And this point is special. It looks like the center of the graph. Exactly, it is the symmetric point of the graph. We will move this point left 2 units become this point, and we continue to shift up 4 units become this point. And this point is -2 and 1, -1. And we look at these options. We will find the graph which has the center point at the position -2 and 1. It's only option D. And this point is the symmetric points of the graph. The final result is option D. Question number 15. Tom purchased a bicycle for $402.5. It was 15% more than Rich spent on a bike. Alex purchased a bicycle that was 20% less than the amount Rich spent. How much did Alex bicycle cost? This question is easy. We just need to put a variable. Then we set up equations and solve. We put T is the amount of money of Tom. And we put R is the amount of money of Rich. And finally, we put A is the amount of money of Alice. From the information in the question, we have T equal to $402.5. The word this is $402.5. This was 15% more than Rich. That means 1.15 times R equal to T. And Alice purchased a bicycle that was 20% less than. And that means A equal to 0.8 times R. Hence, we have A equal to 0.8 times T over 1.15 equal to 0.8 times 402.5 over 1.15. Maybe we need to use a calculator. Uh, 0.8 times the fraction 402.5 over 1.15. That is 280. Option D. We continue. This is the final question. The area of the circle below is 64 pi. We know that the area of a circle it is pi times r squared equal to 64 pi. This means r equal to 8. The measure of the arc ABC is 4 pi over 3. This equals to 4 pi over 3. First, we need to find the perimeter of a circle. The perimeter of the circle is 2 times pi times r equal to 16 pi. Next, we will find the area of the non-static region. This one. We call this x. We will set up something. That is 16 pi corresponding to 34 pi. And this is the perimeter, and this is the area. And 4 times pi over 3 corresponding to the variable x. We have s equal to 4 times pi over 3 times 34 over 16 pi. We cancel pi. 34 divided by 16 is 4. The final is 16 pi over number 3. To find the area of the static region, we just take 34 times pi, subtract 16 times pi over number 3. We use the calculator for faster. It's 34 subtract 16 divided by number 3. That is 176 over number 3. This is option A. We finish.